I am so stoked for this video. In this video, we're going to go over a few problems that go over some of the more challenging types of F prime problems that you'll find in every AB or BC exam, every AB or BC course, and in some more challenging calculus courses in high school and college. And if you just want to learn something cool, watch it anyway. Let's dive. Given the graph of F prime, this is the graph of F prime, the slopes of F, derivative of F. On what intervals is the graph of F increasing, decreasing, and justify your answers? Now, I tell all my students this, don't look at the graph yet. Think of the graph as like a research book. When you write a research paper, you don't read entire books. You go to specific parts of the book based on what it is that you're researching. Same thing here. Wait until we know what part of the graph or parts of the graph we need. So we're asked, where is the graph of F increasing? Well, I'm going to start out with my justification, my reasoning. F is increasing when F prime is greater than 0. So F is, and I'm going to abbreviate here, don't do that on a test. F is increasing where F prime is greater than 0. We know that, right? It's where the derivative is positive, where the slopes are positive. This occurs, and this is where we have to go to the graph. We've reached a logical dead end. Where is F prime positive? Well, let's look at the graph. We're literally saying, where is this above the x-axis? Here and here. So this occurs from negative infinity, and I'll do this in interval notation. You could also do it with an inequality, to negative 2. Easy. And I like to do an open interval, though it doesn't matter. Or it also occurs from 2 to infinity. That's it. So state your reasoning down. That's your justification. And then read it again. It tells you where to look on the graph. Isn't that beautiful? Don't double guess yourself and be like, wait, am I sure? Because the graph's going down here, so that's not increasing. Hang on a second again. F is increasing where F prime is positive. F prime is positive here. End of story. All right, cool. Let's do it for decreasing. Where is F decreasing? F is decreasing where F prime is less than 0. So where F prime is less than 0. And then this occurs, and we need the interval where that occurs on. Again, it's where F prime is less than 0. That's here. That's between negative 2 and 2. So this occurs on negative 2 to 2. And again, you could include negative 2 and 2 or not. It doesn't matter. Done. Justification and answer. Sweet. Another one. Given the graph of F prime, the derivative of F, that's this, at what x value does F have a relative maximum, a relative, I'm doing it out of order, and a relative minimum? Justify your answers. Okay. I'm going to justify it first. Again, ignore the graph. Where does a relative minimum happen? Well, a relative minimum, we'll start with that, occurs when F prime changes from negative to positive, right? When F prime changes from negative, and I'm going to abbreviate, don't do that on an exam, to positive. This occurs, right, literally just write it out like that. This occurs at, now follow your own instructions. F prime changes from negative to positive. These are all the negative values. Ooh, we change from negative to positive right here. So we've got a relative minimum at x equals positive 2. Follow your instructions. Let's do it again. Where do we have a relative maximum? So a relative maximum is where, I'll write it a little bit differently, F prime changes from positive to negative. F prime changes from pos to negative. No abbreviations, but I'll abbreviate to save time. And this occurs, well, let's follow our directions. Well, we're going from positive to negative. That would be from positive, the positive values of F prime, to negative. So that occurs here at x equals negative 2. Done. Another word to the wise. Trust your justification and have it lead you through this. Otherwise, you might be like, oh, there's a relative minimum here. That's a relative minimum on F prime. We're being asked about F. Trust your translation and follow exactly what your instructions tell you. We change from positive to negative for max and negative to positive for min. Done. Look at those points on the graph, and the graph becomes something that is very easy to read. Justification first. Isn't that cool? I think so too. Last one. Given F is differentiable everywhere, and the graph given like below, so on the below, I don't understand why that is there, but below is g of x equals f prime of x. At what value of x will the absolute minimum occur on f of x over the interval -2 to 3? Give a reason for your answer. Okay, this one's a little bit tougher, but first of all, there's a little misdirection here. G of x is f prime. So I gave you the graph of f prime, right? Don't let that fool you. It's the graph of f prime. We want to know where the absolute minimum occurs. Now, an absolute minimum happens either at the endpoints, right? So we check the endpoint, -2, or x equals 3, so that would be right here, all right? Or at the critical numbers, which would be at x equals 0. Why 0? Because that's where, at x equals -2 or at x equals 2. Those would be the critical numbers on f. And you might be like, what, why? Because we're looking to see where f prime is 0. Now let's think about this one. This is why this one's a little tougher. I'm going to go over a different way of justifying the absolute minimum. Notice, if we look at a sign chart here, I think this might be an easier way of doing it. We want to know what f prime's doing on that sign chart. Now, where is the critical number? Well, maybe I'll just kind of do shortcuts instead of arrows here. Just kind of cut it off at the endpoints, -2 and 3. The only critical number, well, there's one at -2, but the only critical number on this interval from -2 to 3 is at 2. Right? That's where f prime is 0, right? And this is the graph of f prime. So if we take a look at this, check it out. Isn't f prime negative the entire time from -2 to 2? And it's positive the entire time from 2 to 3. What that means is f is decreasing all the way until we get to 2, and then increasing everywhere thereafter. So you're going to have an absolute minimum at x equals 2, because there's never a rebound. We never go back down from 2 to 3. So I'll say since f prime, or since g of x, why not, which is equal to f prime of x, is less than 0 everywhere on -2 to 2, and g of x, being very formal here, which equals f prime of x, is greater than 0 everywhere. And I'll justify why that makes sense, that everywhere word is necessary. Everywhere on, and then we go from 2 to 3, the absolute minimum occurs, oh, being very formal indeed, the absolute minimum occurs at x equals 2. Okay, so let me just kind of recap that real briefly. We were given a graph of f prime of x. They called it g, just to be funky, right? We're given a closed interval from -2 to 3. We don't have the endpoint values, so there's no way we could justify this the old way. However, if we notice what the derivatives are doing, what f prime's doing, we can tell where f has an absolute minimum. Looking at the graph, we see that f prime is negative everywhere from -2 to 3. That means that f is going down the entire time until we get to x equals 2. Then it's going to go up the rest of the way after that, which makes for an absolute minimum at x equals 2. Isn't that cool? So that's a different way of justifying an absolute min or max. Slightly harder. You see that every once in a while. Peace.